If a Ferris wheel rotates 2.5 times, what is the angular displacement of the people on the Ferris wheel? So this angular displacement is going to be theta. And here's my Ferris wheel. This is what they look like, right? Person sitting on the Ferris wheel. Oh. And this Ferris wheel is rotating around 2.5 times. Bless you. We're going to look at our two formulas that are given for angular displacement, which is theta. We're going to look at our two formulas and figure out which formula we would use according to the information that's given to us. We're going to use the formula at the top that has rotation, so we're going to use the formula at the bottom that has arc length and radius. The one that has rotations, because here it's saying it rotates 2.5 times. That's my rotation. So I'm going to use this top formula that says theta, which is our angular displacement, is equal to the number of rotations. I'm going to write that as 2 and 1/2 rotations. And I am putting the units in there. The units are going to be important, especially tomorrow when we have to do unit conversions. Today is not as important, but we'll get used to seeing them today. We're going to multiply that by 2 pi radians per 1 rotation. That's something that we learned before. In one full rotation of any circle, that's 2 pi radians. All the way around one circle is 2 pi radians. So that's what this is saying, 2 pi radians per 1 rotation. And then we multiply those together. And since there's a rotation on top and there's a rotation on the bottom, the units cancel. We get theta is 2.5 times 2 pi is 5 pi. And then we bring down our units that are left, radians. That is the angular displacement. If the people rotate around 2.5 times, they're going 5 pi around. This is an exact answer. But when we start talking about real life situations, we sometimes need an approximate. So we're going to find both the exact and we're going to find the approximate for most of these answers. So the exact is 5 pi radians. How do I find the approximate? Put 5 pi on your calculator. And we're going to approximate this to 3 decimals. It does not say to do exact and approximate in the directions, and it does not say 3 decimals in the directions. I'm saying that I should add it to the directions, but it's already printed. I can't. But I'll remind you of that before you do your assignment also. So we'll have approximately 15.708 radians for the approximate. That just means whatever the radius is, these people are traveling that many radii around. Okay, example 2. Determine the positive radians, measure the angle that a second hand of a clock travels through a given time. We got a clock. And it doesn't say where the second hand is starting, so it doesn't matter when I'm drawing my picture here. I'll just put it right here. It does tell us it's traveling 30 seconds. So 30 seconds. We need to find theta. We need to find the angular displacement. Could you do this right now without really thinking much about it? Hi, good. But I'm not always going to give you 30 seconds. I might give you 29 seconds, then it gets a little harder. So we'll go through the process using 30 seconds, but the answer should be pi. Should be. So we're going to use the formula up above that talks about rotations. This does not have radius or length of arc. So it's the rotation formula. It says theta equals the number of rotations multiplied by 2 pi radians per 1 rotation. So the number of rotations is what? Half. And how'd you get half? What'd you do? 60, I just can't hear it. That's 2. The other way around, 30 divided by 60, yeah. So I'm writing this all out like it's a harder question. It's not a harder question. This one's easy. But just in case we get a harder one in our assignment, you would know what to do. So the first thing you're going to do is you're going to put the part over the whole. You're going to put the 30 over the 60. And you're going to reduce that and get that to half. I can also cancel out the rotations, because one's on top, one's on the bottom. And I get a half times 2 pi radian. We multiply that together and we get pi radian as our angular displacement. That's an exact answer. How do we find the approximate? .142 radians. So that would be the approximate to 3 decimal places. Okay, next one's 55 seconds. So we're going to do the same way. We're going to think about rotation. It's going to be 55 out of 60 for our rotation, our part over our whole. Multiply that by 2 pi radians by 1 rotation. Cancel out our units rotation. Reduce 55 over 60. Comes 11 over 12 times 2 pi. So we multiply 11 twelfths times 2, we get 22 twelfths, which is 11 pi over 6. 22 twelfths, 11 pi over 6. And approximate it by typing it in the calculator. 5.760. All right, you try the last one, the third one. C. You try C. That's what I'm running around checking. Oh, he was right under, yeah. Okay, that would be why you got it there. So how many minutes is or how many seconds, I'm sorry, how many seconds is 1 minute and 20 seconds? That's 80, so we need to have a fraction that does our part over our whole, and they've got to be the same unit. So they've got to be both, it doesn't have to be, but there's different ways you can do this. This is probably the easiest way to put 80 over 60, and then reduce it. So you reduce it, you get 4/3. Multiply it together, and we get 8 pi over 3 for our exact radians, and approximately 8.378 radians. Doing okay?
So you don't have to like double, like I just do that, but you have to double like to make it 2 minutes into like that doesn't matter, like if you have to stay 1 minute. If it was like so like instead of like 6 seconds, it would be like 100 seconds to 1 minute 20 seconds.
But how many seconds are in 1 minute?
60. That's what I'm saying. Is like it was like 1 minute plus the extra 20 seconds.
Yeah.
So like I was wondering if you had to double the denominator.
Yeah.
You don't have to double.
Yeah. Yeah, it's still out of, so the 60, the denominator is, well, how many are in one rotation?
Right.
And there's 60 in one rotation. Good question. All right, next one we've got a runner, and he's going around, or she's going around a circular track. So there's my circular track. There's my runner. There we go. Took a while to draw that amazing art. Right there. Okay. Goes around the circular track that has a diameter of 8.5 meters. Diameter of 8.5 meters. Remember geometry, the diameter goes all the way through the circle, through the center, to the end points on the circle. Next part says, if he runs around the track, please get rid of the word entire, because that is confusing and makes it sound like the whole track, but it's part of the track. Get rid of the word entire. If he runs around the track for a distance of 60 meters, what is his angular displacement? So this has him running for 60 meters around the track. That's how far he runs. Which formula am I going to use? Second one, the one that has length of the arc and radius. Now, there's nothing in here that says the length of the arc is, so we have to interpret it correctly. What's the length of the arc? 60, that's around the circle. So that's the arc length, that's the S. And then the radius is not given to us. Well, as you can find it, half the diameter, right? That's like from what, middle school, even further back than that probably? Okay, so half the diameter is going to be 4.25 for our radius. So our formula is theta equals S over R. So theta equals 60 meters over 4.25 meters. And I typed on my calculator and I get a horrible looking decimal. So that, I can find the approximate answer. How do I find the exact answer? 60 over 4.25 is exact, but we never leave a decimal inside of a fraction, so how do I make it so it's not that? Any ideas? I need an exact answer, but I can't have a decimal inside of the fraction. I just need an integer over an integer. Ooh, excellent. Were you thinking money?
Yeah.
Like 25 cents, if I multiply it by 4, I have $1. I make quarters whole by multiplying by 4. So if I multiply the bottom by 4, I also have to multiply the top by 4. If I see a 0.25, I always think money. Or 0.1. Or if I see 15s, I always think of time. Makes it easier to do something. So anyway, we got 240 over 17 meters. You could do it on a calculator too. I was waiting for somebody to say that. You want to do it on a calculator? Math, enter, enter. There it is. Just change it to a fraction. It'll reduce the fraction. Okay, on the back is the formula at the top for our plane.
Would you recommend doing that first?
What, math and fraction?
Yeah.
If math and fraction doesn't work, then it can be written as a fraction.
Okay.
Because if you like put a pi in, it's irrational, never be written as a fraction. So, sure. There won't be many that are, you have to think that way. Alright, so at the top we have arc length. To find the arc length, that's to actually find the length at which my boyfriend curled his box. Not my boyfriend, I'm sorry, my husband. Okay. What? So. And also, my husband doesn't look like that, to say that. It's all a joke. Alright. Arc length is capital F equals the radius multiplied by the angle in theta, which could be the angle formula from the front page, if you don't know it, or they might give it to you. So here the second hand on the clock is 6 inches long. How far does the end of the second hand travel in 15 seconds? Clock, second hand, 6 inches long. 6 inches, I can't write inches. There we go, 6 inches. What did I just drop a picture of? The radius. And how far does the end of the second hand, so right here, how far does it travel in 15 seconds? What am I trying to find? The arc length. I'm trying to find the length around the arc. So to find the arc length, I need the radius and I need the theta. Can you look at this and tell me the theta right now? 90 cannot be theta. Let's talk about why. Has to always be in radians. So 90 degrees, yes, but not in radians. So pi over 2. Yes. But what if I gave you something that wasn't 15? And it wasn't easy to find pi over 2 because we just practiced it for weeks and weeks. If we couldn't find it so easy, then we need to use the rotation of 15 over 60, multiply that by 2 pi radians by 1 rotation. If it wasn't such an easy one, we would need to do this. You know, if I gave you 14 seconds, not 15 seconds. But since I gave you an easy one, we can just check our math and make sure we're finding it correctly. theta equals 1/4 multiplied by 2 pi radians. That is pi over 2 radians. We have the correct theta. Our arc length is the radius, 6 inches, multiplied by pi over 2 radians. And actually, the 6 inches is per 1 radius. So that's how you get rid of the radian units. So we get 3 pi inches. Why is my answer not radians? Not because they cancel that. Why is it not radians according to what I'm trying to find? What are we trying to find? The arc length. I'm trying to find the measurement. If I could possibly take a ruler and curve it around a circle, I'm looking for the inches around the circle. Right, no, totally. That's what you could do, take a string and then measure how long it is. We're not trying to find the angle measurement. That's why it's not radians. We're finding length. So 3 pi inches would be the exact. If we need the approximate, then we'll type in 3 pi and get approximately 9.425 inches. What did I make? Excellent. Find the measure of the central angle in radians and in DMS if the arc length is 5 centimeters and the circle the diameter is 6 centimeters. Here they tell us the arc length, that's the S. They also say the diameter, but I don't need diameter. What do I need? Radius. What's my radius? You need a circle to visualize this. Draw one. I need to find theta. So we'll use arc length equals radius times theta. Arc length is 5 centimeters. Radius is 3 centimeters. Theta is what I'm trying to find. Theta is in radians. How am I going to find it? Divide by 5 centimeters. I mean 3. I said the wrong number. Sorry about that. 3 centimeters. So you get 5/3 radians, or approximately 1.667 radians. It also says to do DMS. Do you remember what DMS stands for? Degrees, minutes, seconds. And there's a button on your calculator, so we will be using that button in just a moment. But in order to take radians and put it as degrees, minutes, seconds, I need to convert radians to degrees. So we need to do a unit conversion. So if we take, and I'm going to use the exact 5/3 radians, and we want to make that into degrees, that means I have to multiply by something that divides out the radians. I need my units to cancel. What do I multiply by to turn it into degrees? 180. Remember this? 180 degrees over radians. Remember that conversion we had a couple months ago? Multiply that together, simplify. We get 900 degrees over 3 pi. 3 reduces, we get 300 over pi degrees. We need to change that into degrees, minutes, seconds. So on my calculator, I do 300 divided by pi. And it doesn't matter if you hit enter or not. It's going to give you a decimal, but we're going to leave that on there. We're going to go find degrees, minutes, seconds. It's under the angle button. we do second, apps, DMS, enter. And it tells you degrees, then it's seconds. Copy it in. That's what I'm going to do. 95. Degrees, 29 minutes, 34.677 seconds. And that's an exact answer. I'm not going to do an approximate for that because the degrees and seconds, we're just going to leave it. Okay?
You said that we did that first step. You said we did that before. Data is equal to 5. 503 radians times 180.
Oh, yeah. That part.
Yeah, that part. We did that part.
Not a whole lot. Because most of what we did last semester was unit circle.
Okay. Is that how you're always going to set up that equation?
If you want to convert it from radians to degrees, you have to multiply by degrees and divide off radians. And it's always 180 and pi.
Okay.
Okay? And you'll see the reverse of that in the next example. But we didn't use it a lot last semester because we were kind of, for the most part, sticking to things on the unit circle. And then this unit, we're going to do things that are more real life. And real life's not always the unit circle. So we're going to have a lot more decimals and calculators at this semester. All right, last example, example 5. The distance between two cities with the given latitude. Oh, we have to find the distance between the two cities with the given latitude. Why does this? Here it goes. Move this away from the wall a little bit. Okay. All of this information is somewhat true. I found it on the internet, so it must be true. The radius of the Earth is 3,959 miles. The latitude for Rome, Italy, and the latitude for Copenhagen, Denmark are given. I looked it up on the internet. We have to find the distance between those two. So when I find the difference between two numbers, we subtract. Start with the big one. 55 degrees, 40 minutes, 34 seconds, minus 41 degrees, 54 minutes, 10 seconds. Subtract. Now these are just like subtracting numbers in base 10, except for they're not base 10, they're base 60. So you still like start with the right side of 34 minus 10. What's 34 minus 10? 24. And then we go to the middle column, we say 40 minus 54. But remember when you subtract numbers like this, if you have the smaller one on top, you have to borrow. Okay. We're going to borrow, but they're not base 10. So I'm not borrowing 10. They're base 60. So I'm actually borrowing 60 from this one. I'm going to cross this out and make it the D4. I'm going to borrow 60, so I'm going to add 60 on here. And that's going to be 100. So we're borrowing 60. Base 60. Subtract those, we get 46 minutes, and then subtract those, we get 13 degrees. If that was way too hard for you, you could also type it in your calculator and do it.
Why do you use 60?
Because we're a degree and like using clock like minutes.
Okay,
Yeah, that's why. But if you're ever to go into anything that you're finding length of land, like what we're doing right now, it's going to be, they use this form of measurement. Like surveying, which by the way, surveying engineers make a lot of money. Well, I guess depends what you think a lot is. More than a teacher. So maybe that's a lot. Like starting salary more than a teacher. But they would use this kind of measurement rather than decimals. Anyway, so this is the difference between the two. Now we're going to find the arc length, so we need to use the formula S equals the radius times theta. This is not quite theta. Anybody tell me what's wrong, why this is not theta? It's not in radians, it's degree form, so we have to convert it to radians. To convert that to radians, we're going to use our conversion, but we're converting it to radians this time, so since we're starting with 13 degrees, 46 minutes, 24 seconds. We're going to multiply that. Since that's degrees, we're going to divide out the degrees, multiply it by the radians. So we have radians left over when we're done. So we're using that same conversion factor, just flip it so we have radians when we're done. Like the degrees will cancel out with the degrees. Now I'm not going to do that yet. I'm just going to wait to the end and type it on my calculator because I can't do that. Let's be honest. It's not going to happen. So I'm just going to put this is my whole theta. That's theta. I'll put that right there in that top. What's my radius? Yeah, right from the directions there. 3959 multiplied by theta, which is right up there. And I'm just going to use my calculator. I'm not going to find an exact answer for this. It's too complicated. So 3959 multiplied by 13 degrees. And I would like you to try this. Make sure that you type it in your calculator correctly too and check with mine. So when you type it in your calculator, you should get about 951.704 miles. If you didn't get that on your calculator, please ask so I can figure out what you came on your calculator. If you solve this whole question in your homework and you write 951.704 radians, I would take off. That tells me you don't understand what you're actually trying to find here. You're trying to find the distance between two cities, and when you write that distance in miles, you divide by 100, so 180. So second enter, you don't recap it, and then you go just on top of that 100, just change it into 180, just the right over it. Way else, I'll cover it. Again, make sure that you have the unit miles so that you get used to writing those correct units. Because with radians, that would be totally wrong. Okay. I'm going to have the assignment. I'm putting up here. The assignment did not have find the exact and approximate to 3 decimals written on it. Doesn't have that. So I'm making sure everybody knows that's what we're doing. And then, with the exception of those ones that you have to do the DMS, you don't have to do both answers for those. Because that's too complicated. Yeah.
So,
No, it's 6. So I moved 6 to the first, and 6 plus 40 became 100. So if I needed a bar over here and use 6 to the first, then this would be like 104. You just need 6 to the first. But you can just type in the calculator too. I just, sometimes typing in all this blocking is just easier for me to do it that way. But you can totally use your calculator for that too.
okay.